Nitin next, we're going to talk about, as you rightly said, on-demand side management, because we've been hearing since morning on the supply side issues, right? We've heard Dr. Mathur talk about it, and Mr. Anil Jain talk about it. Navroz gave us a broader picture about the climate change challenges and opportunities. And Nitin, so from your perspective, since you've been working significantly in this field, it would be good to hear from the demand side perspective, what are the opportunities that we still have?
Hi, good morning everyone. It's great to be here. Thank you to Ashish Garg for inviting me and to Professor Karandikar for gracing this occasion, and of course Sudhakar for being here in person with his family at this event of the center. Before I start, just a quick word, if I can take the liberty of saying a little bit about Sudhakar. I'm going to embarrass him a little, because we are sort of co-located in the Washington, D.C. area. And amongst the distinguished NRIs who've gone to the U.S. and have made a mark in a sector, this name pops up all the time. Having led an institution like ICF, which is a preeminent organization in policy and in various aspects, having taken that sector through the times when you had to go through mergers and acquisitions and things of that nature, it's a different way of thinking. So I want to acknowledge your alumnus as someone who's recognized in that sector all over. So kudos on that, and so happy to be here for that reason. Navroz was right. I am going to speak about the demand side. The demand side means the end users. There are two ways of looking at energy planning. One is from the supply side, or several ways, but two dominant ways. One is to look at it from the supply side. To say broadly how much energy we require, and to say that this is the amount of BTUs or gigawatts that we need, and then say how are we going to get the energy mix and the fuels to actually get us to that point. The second way of looking at it is actually to go bottom up, which is to say what is the energy demand for the end user. And that makes a big difference in planning. The reason is because the kind of energy you require for the end user may be different. Your end use may require mechanical energy or heat or cooling or electricity or lighting. Now, as students of engineering here at IITK, it's important, I think you'll all recognize and appreciate the fact that you need to minimize the number of conversions that you need to do. Because at every conversion, there is something called the law of thermodynamics, which if you try to beat, you will lose. So I think it's really important that depending on the kind of use that you have, you need to look at what is the energy mix that you actually require. Now, in the traditional sense, the kinds of supply forms that we had of energy, which were oil and gas and now electricity, were much more centrally provided. So therefore, the orientation and the political economy around that orientation was very much centralized because you were supplying everything. The utilities today, they're mandated to supply electricity. They are rewarded by the amount that they sell. Imagine it's your top line in your budget. They have no incentive to actually reduce the consumption, to increase efficiency, to reduce what you could reduce even if you're getting the same service. So it took quite a while, back in maybe 15, 20 years ago since, to even do simple things like bringing in CFLs and LEDs into places all over the world, not just India. And the utilities at that time resisted it because it reduces the number of kilowatt hours that they benefit from. It's a very clear-cut equation all over the world. Okay? So you have to see in this whole idea that when we talk about structural transformation in the energy sector, while we'll have certainly all the co-benefits that Navroz correctly pointed out, but if we are talking about a structural transformation in the energy sector, then the question becomes, what does it look like if we simply cater to the actual demand that we had, that we started looking at the customer's needs and started catering to that? What would the world look like? And that's a different question. I'll come back to that in a second while I go through this, and that, as I said, how does end-use driven sustainability and net zero pathways come out when we start looking at the requirements of communities and individuals who actually use the energy that they require to do their job? How does the world look? So let's take an example here. Let's take the example of institutions and campuses. There's a lot of talk. There's a lot of demand around institutions, campuses like this, institutions and companies which have big campuses. Swapnil here is from Infosys, leading large campuses, which have substantial energy demands and so on. What are their requirements? And how can we meet those requirements without having to necessarily say we are going to supply it all only with electricity, okay, or only with gas? How do we actually think about the end user? So here, for example, there's plenty of opportunities. And again, I address the audience here, which is the students of technology primarily and associated areas. So there's plenty of opportunity, and I'd like you folks to see the opportunity that Navroz was alluding to in terms of what all can be done. And that there's a very different world out there when you start thinking about end-use driven, customer-driven opportunities. So here, for example, there's plenty of opportunity to characterize and manage the end-use total energy demand, whether it's electrical, mechanical, or chemical, both heating and cooling. And there's plenty of technologies that are available out there to address the customer demand. Examples of that, net zero buildings. And again, I refer to Swapnil because some of the amazing technologies that were utilized in the building of their campuses were catering to their own demand. So here you've got minimal energy conversions. For example, we can look at radical shifts in building materials and techniques that we seem to be simply glossing over. We still have people doing wet construction, guys out there laying out those gunny bags and putting water on top and waiting for the sun to shine and changing that. Okay? Amazing amount of work can be done in dry construction, which can save a huge amount of energy. You can use a full range of dispersed energy sources, not only solar photovoltaics, but as Ajay Mathur said correctly, they will coexist with other sources where you hybridize them with small wind turbines, hydrokinetics, pumped storages, and so on. It's not only electricity, because we tend to focus on that because it's easy. But I think we need to look at the customer first. And lastly, usable storage. While you have EV charging and so on, all good developments in technology. So I kid you not, I'm not knocking it down. But there are other things that can store energy, like flywheels, compressed air systems. And here you need a substantial amount of policy support so that there is a certain amount of grid interactivity that can be done, especially for larger installations. Okay? Not necessarily for smaller installations. As Navroz also said, there are some co-benefits that you can start thinking about because these are multidisciplinary areas. So the amount of energy that you require for our customer needs, which is waste to energy changes or treatment of water and wastewater, these are all energy intensive processes. And you need to, the electrical engineers need to work with chemical engineers and biotechnologists in order to try and capitalize on what energy savings can be accrued to achieve the same goal, but with better and more efficient energy uses. So you're again coming in from the demand side. There are also different things that you can do for cooling, whether they're plantations or green roofs, but they also help you, as Navroz said, in terms of co-benefits and also adaptation and resilience in terms of actually restoring what we've messed up essentially, which is our land. Almost 40% of India's land is degraded. It's a horrifying number. But therein lies the opportunity actually of restoring it. It's a different way if you actually turn the tables and say, I have an opportunity to actually improve something. And there is a desperate need for that. And lastly, there's a huge opportunity at the local level as well as at the policymakers level to look at skill enhancement in a very different way across departmental silos. I remember some years ago when I went in with a program to the government saying that we need to train our plumbers better. This was to the power sector that I went to. Why? Because it saves energy. In fact, if you go to all our major cities, they have this pump set that's over there, which is terribly installed with kinks and everything else, and they pump the water. When the chowkidar turns on the flips the switch in the evening, and they pump the water over there, and then they feed it by gravity, right? But these pumps are terribly inefficient. And just a simple pump replacement program can save a huge amounts of energy for the cities and for India. This is a simple concept. It doesn't take rocket science. But you know what the answer was that I got? We work with power and electricity and not with plumbers. So such simple departmental collaboration to retrain and do skill enhancement, but actually monetize that in terms of what is real as a real commodity, which is energy. And so energy-based design actually provides you a tremendous way of addressing this issue, which also results in climate benefits. Another set of communities that you can look at are rural communities. They have an amazing amount of latent demand for efficient applications for many, many specific end users. There are design linkages between sustainability and net zero pathways where you can look at not only the current demand, but community aspirations. Remember, people are moving to urban areas for good reasons of their own. We can't just critique them. We have to understand their aspirations. And to address that, you need to address their local energy needs using decentralized and dispersed energy. And those needs, as Navroz was saying, they may not be just energy needs. They may actually be different needs related to nutrition, to health, sanitation, and so on. An example here. We have solar-powered irrigation pump sets, a big program. Now, there's nothing wrong about solar-powered irrigation pump sets. Technically, no, nothing at all. But in many cases, you find, especially in water-scarce areas, that promotes more pumping of water and more wastage of water. Actually, for the farmer, if you gave him water and didn't care about energy, he actually wouldn't care. The end-use demand is for water. It's for water management. So you could actually be saving energy and using energy in more efficient ways if you actually looked at the customer need and the demand. Now, when you scale that up to thousands and thousands of people, that's when you start seeing sort of the system effects of it. There are opportunities to hybridize energy. New areas are popping up all over the world. Agrivoltaics in Germany, low-head hydro in Japan, small wind applications all over the place, including some research that I was told about yesterday at IIT Kanpur here. including vertical axis wind turbines. Biogas, these are all to suit the end use patterns. Who's your customer? And that's the king that we want to pay attention to. Now, there are many other examples that I can talk about. One of them, for example, in post-harvest processing. Almost 30% of our food goes waste because of the problems that we deal with in storage, including when we have what were government programs for cold storage facilities, which are largely empty because of their pricing patterns, inefficiencies, and so on. But there are actually many other storage methods out there, and tremendous amount of technology required and interventions required that can improve on storage. Okay? And some of these are being tried out in different parts of India. It's worthwhile for students and for the center to actually get to that level of community and end-use engagement to understand what the real requirements are and capitalize on the opportunity that Navroz talks about to restructure our way of thinking so that we cater to our customer needs and not necessarily to the needs of the suppliers. And this is where I'm going to end with just one last question for everyone, and including some of the panelists. It's true that this is painful, as Navroz said, and as Ajay Mathur, my good friend, indicated, that this is a painful transition. Ajay talked about and Navroz talked about the reducing price of solar. Again, I think the focus is on electricity. And these are prices reducing at the bus bar. And as we saw yesterday, these are not prices at the system level. They're very different. And that's because at the system level, the prices are influenced by the inefficiencies of our outdated, outmoded grid system. There is a tremendous amount of work that can be done by the power systems group that can actually rethink the way in which the grid itself works. And in fact, in a distributed energy system, which is what is needed in order to meet the demands of the customer, what is in fact the role of the grid? What is the role of the grid? And I think this is an important question. It's an important policy question. Does the grid simply need to be always that supplier that it was originally intended to be? And has the role changed, and what does the new grid look like? It's not that there isn't work going on this. There is some work. But I do think we need to take, if we have to address the climate issue, then we've got to take a radical approach to this and ask this question head on. What is the role of the utilities which cannot yet, to date, not only in India but elsewhere, support a distributed system because it is a loss to their revenues? That's a fact. And it's an old fact, it's not a new fact. But we're at a situation driven by climate and other issues and other, the opposite of co-benefits, I guess. These are societal facts that are driving us towards a structural change. In order to address them quickly, and that time is imminent, as Navroz was saying, 10 years is not a long period, folks. 20 years is not long, okay? And 50 years is not long. My grandchildren will be 50 by that time, in their 50s. And I'm concerned. So I think it's important when we say what is the structural transformation and a radical transformation, we have to ask the hard question. And we should not be sitting idle by saying, maybe we can make some changes along the edges here and start thinking about adding a few things to the grid and some new equipment and try and see if we can accommodate some mini grids and so on. No, it's not satisfactory. The question is not satisfactory. And I think as engineers and technologists, we should not take no for an answer. And with that, I thank you.
Nitin, you talked about inherent inefficiencies into not wanting to accept solar generation. Now, I just want to understand, sometimes you may have a player who is not ready to change, but what if I find it profitable to just set up my own independent rooftop solar with storage and just stop taking from the grid? Right? So, do you think that's the scenario that will happen in the future? Because customers will say, okay, the grid is not cooperating, they are not kind of having a consistent net metering policy. So, let's me just kind of put a rooftop solar on my establishment or on my house or office or whatever it is and just forget about those guys. So, they kind of sort out among things among them. So, is that a scenario?
Yeah, there will be customers who get tired of not being properly serviced by the utility system as it is, and they will go off grid, and there's plenty of opportunities for customers to go off grid on their own just by being dissatisfied. But I'll add a plus to that by saying that as Navroz was saying, what's the economic reason also for off-grid? We heard about, and we keep on hearing about the agriculture sector being not profitable for the grid. And that they've been cross-subsidized by the higher tariffs on the commercial, industrial, and so on. Doesn't it make sense that, in fact, the utilities would be more interested in actually having their unprofitable customers, the agriculturists, be off-grid? That they are not dependent on them? And that they don't have to cross. In fact, wouldn't the commercial and industrial sector be interested in not having to cross-subsidize by saying that actually we don't want the unprofitable customers, and be able to support those kinds of installations that you're talking about over there, which allow them to go off-grid? Now, isn't that an economic and a financial reason for both the commercial industrial customers as well as for the utility to actually promote off-grid dispersed solutions so that they can become more profitable? I'm not even talking about climate change. So I think there are very good reasons why people would go into off-grid, in addition to customers themselves being simply dissatisfied, which I suspect some of us might be.
Last remark. Just very quickly to a question that came. I think if I recall, there are few number of households in Pandit now who actually gave up their grid connection, and they are fully dependent on their solar and the storage in their house. And this did happen, but I think they are, it's an outlier because they are a different class, because they are rich also and they are much more educated and concerned about it. Briefly on this, whether industrial consumers or the agriculture consumers would like to go off the grid, we have a program called PM Kusum. This is for solarization of pump sets, A, B, C, different schemes. Again, the offtake is very small. Precisely the reason is because we have made them so used to free power, and anything that government wants to do, they are suspicious about it. You are doing today something and now you are going to do something else, so let me not do it. Industries will not probably go. In fact, as of now, a number of industries, not just renewable, they are buying it from the market through open access. They are not giving up their connection with the distribution company, precisely from a reliability point of view. They retain, they keep on paying demand charges also. Most of them will do that for the original load. Because they say, I never know, I may not get it if it's not reliable. Electricity is not my business. My business is producing X, Y, Z. Thank you.
Thank you so much. So,
I just want to make a quick addition to that. I think it's important to also think about the economics of the grid. So if I am sold a storage and I have connected to the grid and there's wind power and there's hydropower and there's other sources of generation, I can get away with, let's say, 3, 4, 5, 6 hours of storage. So it is going to be economic. Where as soon as you disconnect from the grid, you need to have enough solar and storage for the cloudiest day of the year. So you actually need 24, 48, 72 hours of storage. So I think for, say, Andaman and Nicobar or Ladakh, or somewhere there's a lot of diesel generation, that could make sense. But for, say, IIT Kanpur, it's still going to make sense to be connected to the grid.
Thank you. No, I mean, although we've seen in this case of solar agriculture farms, farmers are disconnected and gone complete because when they, during the monsoon when they don't need solar power, the rains is available, so that it works in that. First of all, thank you so much, Navroz, for staying back and throughout the session. Thank you so much for your perspective. Nitin, thank you, and for saying thank you so much. And my apologies for not managing time well enough and delaying the session a little longer and keep carrying forward. But once again, thank you so much for your valuable insights.
Thank you very much, Navroz, for joining. Thank you very much.